Okay, here is another question on data frame. How do you remove all the rows in a data frame that has NAs? So this is probably one of the most used operation in data cleansing on a data frame. Now, whenever there is no data in a data frame, it's listed as an NA. So that's how R treats unavailable data. But when you want to do some kind of an analysis or when you want to do machine learning, NAs don't work. Meaning, basically, they render the entire row useless. So if there is an NA here, what meaning can you extract from this row? Nothing, essentially. Because when you don't have certain attributes, you can't really qualify that particular row. So there are a couple of methods to deal with this, like using averaging or using some kind of a smoothing function. But if there are just a few NAs, let's say there are 10,000 records, and you just want to briefly go through it and say, okay, there are a couple of NAs, maybe 10 rows, and removing those 10 rows, it's no big deal, right? Out of 10,000, removing 10 rows is not going to be a big deal anyway, either from an analysis perspective or from a machine learning perspective. So in that case, you might not want to do a whole lot of logic to replace NAs with whatever values you want to put in, like an averaging or smoothing. You just want to lose them. How do you do that? Remember, these NAs are not just in any one particular column. These NAs could be anywhere. For example, if NAs are only in this column, let's say column A, like so, and this has some value, let's say Virginica. In that case, things are very easy. All you got to do is say iris underscore new equals iris of col A is not equals NA, and then that should give you all the rows that does not have the NA. But that's not how it's going to work in a typical data frame that you get in real life, right? The NAs could be anywhere. You don't know where the NAs are. You just have to make sure that all the rows that have some kind of an NA in any of the columns have to be gone. How do you do that, right? So we are going to lose this row because it has an NA. We're going to lose this row because that has an NA, and delete this row. So this row goes in, this row goes in, this row goes in, and this row goes in. So we want to just filter the data frame for only those rows that does not have an NA. How do you do that? So let's see. So how do you do it? So let's actually create a data frame, this small data frame, right? Then let's go through this step by step. Well, you could skip all this and you could just use the command like this, but or use any other available off-the-shelf functions to get rid of NAs. But the reason why I'm taking you through all these steps is because I want you to understand what's really going on behind the scenes. So let's create this small data frame that has just 4 rows with an NA here and an NA here. Okay, so persons is these 4 rows. Persons equals data.frame, it's a blank data frame, and persons equals edit of persons. So we want to create this new data frame. Like how? Like so. The first column is age, name, city, and then zip code. Okay, let's see what this data frame has. Okay, that has 2 NAs, right? City is an NA and age is an NA. Okay, so we want to remove those 2 rows. The way to do it is by doing this. There's one big command for it, but I want to break down that command for you. The reason why we want to do that is we want to understand what's going on step by step. All right, so what's the first step? The first step is to identify which of the values in that data frame is an NA and which of them is not. The way to do that is by saying is.na. So when you say is.na of that data frame, it gives you a list of true and false. True says that it's an NA, false says that it's not an NA. Okay, so this is NA, the first row column, and that's true. And this one is an NA, and that's true. And everything else is false. Makes sense, right? Okay, now we want to inverse that. And we're going to learn why we're going to inverse that in a minute. Meaning, we're going to say false is true and true is false, right? Okay, and then only these NA values are false and rest of them are true. So we want to essentially extract everything, or extract all the rows where at least one of these values is false. Makes sense, right? So how do you do that? So this is all true and we want to retain that row. This is all true and we want to retain that row. But this is not all true. One of the values is false and we want to lose that row, right? So what is step number 3? Step number 3 is to apply a function that says if all the values are true, then leave it as it is, return a value of true, meaning, but if at least one of the values is false, return false. So the function is all, and let's say all of this particular thing. So this is a data frame, right? True or false data frame. So let's take the first data row. It's not persons 1, it's persons, right? So this is false. What does that mean? The first data row, not all the values are true. Now let's take the second. Same thing, right? Not all the values are true. Third, this is true. All the values are true, right? So when you apply this function all across all the rows in this data frame, it will give you essentially all the rows that needs to be lost and all the rows that needs to be remaining in the data frame as either a true or a false, right? So when you want to do that, you want to use the apply function, which applies on all the rows in the data frame, right? Like so. And what does it give you? Let's go over this. So what we are trying to do with this apply is apply on this data frame, of course, and one says go row by row, go row by row. You could do it column wise as well, but we want to do it row wise, right? Go row by row and then apply the all function. So takes the first row, applies the all function. When you apply the all function on this, this has a false, true, true, true. And then only when all the values are true should a true be returned. In this case, there is one false, so this returns a false. Go to the next row. True, true, false, and true. That's a false too. Third row is true, 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 and true. That's a true. And the fourth row is true as well, right? And that's what you see here. False, false, true and true, true and true, right? Okay. Now you can put all of this together using this command. Say persons is just this row 3 and 4, and the first and second row are lost. So we are essentially applying the all function. So this is the function that is being applied across row by row, all rows, on this true false data frame, and the final list of true falses will be available here. This is false, false, true, true. And when you pass that into a data frame persons, all the false rows are lost and only the true rows remain. That's what we are trying to do here. So if you look at this entire thing, it's a little confusing, but if you break it down step by step, it's not a big deal. So the first step was identify which of these values in this data frame is an NA. You inversed it because that's going to be useful when you do the logical operation for true. You need not do it exactly this way. You could do it any other way, but this way is easy. And the third step is to find out all the rows where all the values are true. Even if there is one false, lose it. And the fourth step is applying that on this data matrix true false data matrix or data frame row by row. And that's what you're doing in this apply. Row by row, apply the all function. Finally, you plug that into the rows index of the person's data frame, and then you only remain with the rows that don't have NAs.